Welcome to the channel. Here, in this episode of Untold, we'll explore the history, impact, and future of quantum physics. What makes quantum different? Quantum mechanics is not like normal science. It describes a world where particles can be in two places at once or act like both waves and particles. This might sound crazy, but it's been proven true by experiments again and again. Take the double-slit experiment! Here, an electron gun fires individual electrons toward a screen with two slits cut into it. If electrons were just particles, they'd go straight through the slits and hit the screen like this. But actually, they spread out like a wave, hitting the screen in an interference pattern. This happens even if you send electrons one at a time. If each electron goes through both slits simultaneously, acting like a wave, but as soon as you put something in front of the slits to measure which slit the electron goes through, the wave-like behavior disappears and you get the particle-like pattern. Reality seems to change depending on whether we look at it or not. And that's not the only example. There are many other ways that quantum objects like electrons, photons, and atoms don't behave like we expect them to. So what's going on here? Well, in a nutshell, quantum mechanics says that nature works in fundamentally different ways from the world that we experience. At the atomic and subatomic level, things are unpredictable, random, and unexpected. And as we'll see next, this has huge implications for how we understand the universe. Now, while quantum mechanics might seem like a trendy and futuristic idea, its roots go back over 100 years. It all started in 1900 when German physicist Max Planck was trying to figure out why hot objects glow. As he worked on the problem, he came to a shocking conclusion. He realized that energy isn't continuous, but comes in chunks or packets. These packets, which we now call quanta, are like tiny building blocks that everything else is made of. It was a big idea, and it won him the Nobel Prize. Most physicists only took quantum theory seriously after Einstein explained the photoelectric effect. This is what happens when light shines on metal and knocks electrons out of it. Classical physics couldn't explain this, but Einstein had an idea. What if light itself was made of these quanta, which he called photons? His explanation was controversial, but it turned out to be right. These discoveries shook the very foundations of physics. They showed that Newton's laws and all the classical physics that had come before could not describe the behavior of light and matter at the atomic level. There was a hole in our understanding of the universe, and over the next few decades, some brilliant minds set out to fill it. The first quantum theory described how energy is. Then came the discoveries that really changed everything. Electrons and photons don't behave like particles, but like waves. Heisenberg's uncertainty principle. In 1927, Werner Heisenberg showed that there's a fundamental limit to what we can know. You can't know both a particle's position and speed at the same time with perfect accuracy. The more precisely you measure one, the less you know about the other. Think of it like trying to catch a speeding car. Switching on the radar gun shows the car's speed, but it also shifts the car's position. It's like Schrödinger's cat. In 1935, Erwin Schrödinger thought up a famous thought experiment. Imagine a cat in a box with a device that has a 50% chance of releasing a deadly poison until you peek inside. The cat is both alive and dead. Wild, huh? But it illustrates a real idea that quantum objects can be in two states at once. This is called superposition. Like a spinning coin that's both heads and tails before it lands. This may seem like a joke, but it's serious physics. Large objects like cats aren't affected by this because their atoms are too big. But at the atomic level, it's a common phenomenon. It's what makes quantum mechanics so weird, how quantum physics changed the world. But quantum mechanics isn't just a curiosity. It's powered much of the technology that we rely on today. Semiconductors, transistors, and microchips are made of semiconductors, materials like silicon that conduct electricity under certain conditions. The fact that they conduct electricity in this unique way is due to quantum properties. This was a major breakthrough, leading to smaller, faster, and cheaper electronics. Today, we rely on these chips for everything from smartphones to smart cars. Lasers, light amplification by stimulated emission of radiation. Lasers work by stimulating atoms to release photons. This makes a bright beam of light that's used in barcode scanners, laser surgery, and telecommunications. One of the most important applications is in fiber optic internet, where lasers carry data around the world. MRI machines. MRI machines use powerful magnets to line up atoms in your body, letting doctors peek inside without any radiation. GPS. The Global Positioning System satellites rely on atomic clocks. These clocks are so precise because they use the quantum properties of atoms to measure time down to 1 second every few million years. And don't forget LEDs, touchscreens, and solar cells, all of which rely on quantum physics. In fact, our daily lives are full of quantum effects. Modern quantum science. But quantum physics isn't just a thing of the past. It's a vibrant area of research with lots of potential. For example, quantum computers could revolutionize medicine by helping researchers develop new drugs or understand diseases better. They could also help model the climate or improve artificial intelligence. Unlike regular computers that use bits, which are either 0 or 1, quantum computers use qubits, which can be both 0 and 1 at the same time. This might sound like a small difference, but it means quantum computers can do some things that would take regular computers millions of years. Quantum cryptography is super cool and game-changing. This allows two people to share secret information that can't be. This is because measuring quantum states changes them. If someone eavesdrops, they can mess with the info, alerting both the sender and receiver. It's like having a super secure, safe. These are just some of the ways that quantum science is shaping the future. Why 2025 matters. To show how quantum science is affecting our world, the United Nations declared 2025 the International Year of Quantum Science and Technology. This is a chance to celebrate 125 years since Planck's discovery and recognize how far quantum physics has come. So there you have it, a whirlwind tour of quantum physics. It's a field that's changed our understanding of the universe and continues to shape our world. Who knows what the next 100 years will bring? Maybe we'll unlock the secrets of the universe itself. If you enjoyed this untold science story, so please subscribe my channel for more fascinating journeys into the hidden side of science.